We will be looking at June 2022 paper, question 19. In this question, it's about acids and buffer solutions. Starts off with succinic acid, is a weak dibasic acid because it's got two carboxylic acid groups that is used in a tablet form in health supplements. A student plans to determine the mass of succinic acid in one tablet of the supplement. So the mass of acid in one tablet. Now, so the student decides to carry out titration with potassium hydroxide, and you've got the equation there. You can see that potassium hydroxide reacts in a 2-to-1 ratio. So we'll come back to this point when we do the calculation. The student uses the following method. The student crushes four tablets, and dissolves them in distilled water, makes up the solution to 250 centimeters cubed. The student then titrates 10 centimeters cubed of this solution, so that's originally come from here, portion, with this concentration, potassium hydroxide, using phenolphthalein as the indicator. So you got your table of results there. Now, complete the table and calculate the mean titer of that the student should use for analyzing the results. So let's have a look at this. The calculator for the second result, so titration number 2, gives you this on the calculator, but you must add in the 0. All the results must be to 2 decimal places. Just remember that, ladies and gentlemen. The last one, 25.75. 22.55. Now, in terms of choosing the results, the titers for the calculation, we do not use the trial result. Trial is a rough approximate. So that rules out titration number 2 because that's the closer value to it. Even though it's 0.05 apart, we will be using results 1 and 3. And by adding them together, 22.45 plus 22.55 divided by 2, that gives you 22.50. Moving on. Use the student's results and equation 19.1 to calculate the mass in milligrams. Mass in milligrams of succinic acid in one tablet. Okay, you see, just to give you a quick visual, we added 4 tablets and we made up the solution to 250. We then titrated 10 centimeters cubed of that. And the average titer we got was 22.50 that we just worked out. Now, in terms of working out the mass of succinic acid in one tablet, we do the following calculation. Now, the concentration of potassium hydroxide is given as 0.06. Okay, we've got all the information we need there. Let's start processing this. What we got for potassium hydroxide, we've got volume times concentration. Volume, that's your average titer, divided by 1,000 to convert into decimeters cubed, multiplied by the concentration, gives you the moles of potassium hydroxide used in the titration. Now, it reacts as a 2-to-1 ratio, just as a reminder here, 2-to-1. So 2 moles of potassium hydroxide react with 1 mole of succinic acid. So how do you make 2 into 1? We divide that by 2. So for succinic acid, it's going to be 1.35 divided by 2 because of the ratio. Now, that's how much is in 10 centimeters cubed. How do we work out how many moles of succinic acid is in 250? We need to multiply it by 25. That scaling factor is this, from here to there. So you multiply it by 25. This gives us so we've got the moles. We've got the moles of succinic acid in the 4 tablets. We've got the moles. Now, what we want to do is work out what the mass would be. So we need to multiply this by the MR of succinic acid. What is the MR? Let's work this out here. This is 45. The COOH is 45, 45. I've got 14 and 14 in the middle. It's 118. So 0.016875 multiplied by 118. That gives you the mass of succinic acid in the 4 tablets in grams. We want to divide that by 4 to work out the mass in grams in 1 tablet. But we then want to convert the grams into milligrams. How do you convert grams into milligrams? We multiply it by 1,000, and that will give you your answer. Give your answer to 3 significant figures. So that gives us 497.8125, 498 milligrams. Yep, and if we look at the mark scheme, it supports that. Where are the 5 marks in this question? Volume times concentration gives you moles, dividing it by 2, multiplying by 25, multiplying it by 118, and dividing it by 4 and multiplying it by 1,000 for the 5th mark. Moving on, you've got a another carboxylic acid, glycolic acid. You're given the pKa value of this weak acid. And it's used in skincare products. A buffer solution is prepared by adding this volume, this concentration of glycolic acid to this volume and concentration of potassium hydroxide. Explain why a buffer solution is formed. Let's have a look. Volume times concentration. Here you got 0.045 moles of glycolic acid. And here you've got 0.025 moles of potassium hydroxide. So you see, HOCH2 glycolic acid reacting with potassium hydroxide to give you the salt and water. And you see, when it reacts together, what you're going to be left with is all of the potassium hydroxide gets used up. We've got excess weak acid. So after the reaction takes place, we'll be left with 0.025 moles. This will be 0, and we'll get, it reacts in a 1-to-1 ratio, so we got 0.025 moles of the conjugate base, the salt, the potassium, glycolate. And explain, so I think we've done a bit of the part 2 of the question. Why is a buffer solution formed? It's because the glycolic acid is in excess. Glycolic acid in excess. And because it's in excess, you've also got the salt that is produced. And you can call it glycolate or the potassium glycolate or the salt. Sorry, you can allow, it allows conjugate base and its conjugate base, which is the potassium glycolate. Is formed. Hope that makes sense. You need to include both marks for the question. This question, the first one, why is a buffer solution formed? This comes up many, many times. Whenever you have a excess weak acid reacting with a base, it always forms a buffer solution. The next part is asking you to calculate the pH of the buffer solution. Now here, so we've got Ka is equal to, now we've got our glycolic acid, so let's write the glycolate ion. That's the glycolate ion, the salt or the conjugate base. Got your H+ ions. And we have the glycolic acid, the weak acid. That's the expression. And because this is a buffer solution, ladies and gentlemen, this does not equal H+ squared. No, no, no. These are not the same as each other in a buffer solution. In a weak acid only, that assumption can be made, but not in a buffer solution. Please be mindful of that. So we've got all this. How do we work everything out? Ka will be 10 to the power of 3.83 minus 3.83. That converts the pKa into Ka. The weak acid concentration is going to be 0.025 moles. Where did I get that from? From over here. Divided by, what's the total volume? The total volume is 100. 40 plus 60, that's 100 centimeters cubed in decimeters cubed. Actually, that's that concentration. The salt is going to be 0. Wait a minute, I think I made the wrong calculation here. 0.4045 subtract 0.025, that here should actually be a 0. So that should be a 0 there. Okay. And for the conjugate base, the salt concentration will be 0.025 divided by 100 over 1000. That gives you 0. So let's just plug all this in and work out the H plus concentration by rearranging. So let's get Ka first. 10 to the power of minus 3.83. Let's multiply that by 0.20, which is the weak acid, and then divide by the salt, 0.25. That gives you 1.18328 times 10 to the minus 4. And minus log to the base 10 of this value gives us I've got here 3.93. They want it to 2 decimal places. And the mark scheme supports that. Hope that makes sense. And looking at the last part of the question, a small amount of aqueous ammonia is added to the buffer solution. Explain in terms of equilibrium how the buffer solution would respond. Now, you see you've got glycolic acid. Let's just write this down. Let's get the formula. So we got glycolic acid. And in the buffer solution, you've got your conjugate base. Your H plus ions there. So really, just going a little bit off topic, you got in a buffer solution, you've got a large reservoir of the weak acid, a large reservoir of the salt, and you've got a tiny bit of your H plus ions. And what keeps the pH of the solution somewhat stable is this large reservoir of the weak acid and its conjugate base. So it's asking what happens in terms of when you add a little bit of ammonia. You see ammonia, when ammonia, there's couple of ways of doing this. When ammonia, when it reacts, when you add it to an aqueous solution, it reacts with the water to give you NH4 plus and some hydroxide ions. Those hydroxide ions will then lower or react with the H plus. It will decrease the H plus concentration. And so to oppose that change, the equilibrium will shift to the right-hand side to oppose change. Because OH minus ions react with H plus. Let's have a look at the mark scheme. 1 mark is for ammonia or OH minus ions react with H plus. So you get a mark for this. The second point is that we need to give the equilibrium. We need to write this down. That's worth half a mark of the second point. And the other half is the equilibrium shifts to the right. Yeah. That's it for this question. All done. I'll see you next time.